All right. Hello, everyone, and welcome to SIG scheduling meeting. Today, we are going to talk about mostly a quick update on 1.11 and then mostly our plans for 1.12. For 1.11, as far as I can tell, and until last night, everything has been going well. I haven't checked emails much in the morning today, so I don't know. Hopefully, everything is still going well. We are on track for releasing priority and preemption as basically enabled by default in 1.11 as a beta version. And basically everything so far has been good. We have been a little bit worried about scalability of the feature, but luckily we don't see any major issues there. And with respect to, first of all, if you have any questions about 1.11 and anything related to the release, please ask them now, and then we can talk about our plans for 1.12. All right, so with respect to 1.12, I have several things in mind, but I would like to also collect your ideas and feedbacks and incorporate them into our plan for 1.12. The several items are major ones. One is improving performance of a scheduler. There are a couple of plans for doing that. One is to improve performance by enabling equivalence cache. Jonathan and Harry are working on that, and I'm hoping that we can finalize the work in this quarter and move that feature to beta. More recently, just a couple of days ago, when I tried benchmarks with the equivalence cache enabled, I faced some of the issues with respect to basically the benchmarks timing out in a larger cluster, like 5,000 nodes, 10,000 pods. They were not working well with equivalence cache. These issues should be investigated, and further tests probably should be developed before we can move them to beta. We also need to make sure that equivalence cache indeed improves performance, because sometimes, so far what we've seen is that sometimes the locking mechanism of equivalence cache, which is sort of like a global lock on the whole structure, causes problems for us, particularly because equivalence cache is sort of a funnel right now that all of our parallel tasks that run predicates have to go and read from it. We have changed the mechanism to have read lock versus write lock, but I guess write lock is invoked or obtained frequently, so that our read locks are stuck also behind that lock. So we need to investigate some of these issues and try to improve performance of equivalence cache. That's one of the bigger plans. We have taints to move to beta. Basically, tainting nodes by condition should move to beta. We didn't do that in 1.11, but we are hoping that we can do it in 1.12. We are hoping to move daemon set scheduling to beta. Basically, today in 1.11, we have that feature in alpha Kubernetes. We are hoping to be able to move it to beta in 1.12. After it's moved to beta, we can completely remove rescheduler from our infrastructure. Now that rescheduler is gone, we can now, I guess, we are ready to bring descheduler as a standard component of Kubernetes, and as a basically add-on that is sort of like a more, I don't know how to say it, but like a standard version available in the standard version of Kubernetes. And I would like to know how Avesh thinks about that as the owner of Descheduler. Avesh, if you are online, please.
Yeah, definitely. Like, I agree with you. Like, we would like to have Descheduler as like the standard add-on wherever we can use. Yeah, so I agree with that.
Okay.
Yeah.
All right. Thanks. Okay.
I'm sorry. One thing I was wondering regarding that daemon set scheduling by default scheduler, is it possible like there is a like default? I mean, there is a job that we can have something like, I mean, non-critical job, like whenever tests are running, so that side by side, whenever PRs are created, we can see like if we are having any issues or not, something like that, so that we can get some feedback in parallel.
I'm not so sure if I got the idea. Are you talking about like a test that every
Yeah,
time you are?
yeah, yeah. Some
Okay.
sort of job, yeah, CI job that can be enabled by default. Maybe non-critical, it does not stop, but at least we can get some maybe feedback how the feature is doing if we enable that by default during that job.
I see. That's an interesting. Basically, what you were saying is that while this feature is still in alpha,
Yeah,
that test is run by default and allows, basically enables that feature and allows
right,
them to
right.
verify the validity. Yeah, that's actually a good point. If we can do that, we should probably do it. Although I'm not so sure about whether we can enable it in CI/CD. I guess in CI/CD we can have like optional tests.
Yeah,
Basically, if a feature is not so stable, we don't want to block everybody from, or if the test is flaky, or because the feature is not always reliable, we don't want to block
yeah,
everybody's.
yeah, yeah. That's
Like,
why I'm saying like non-blocking job, sort of non-blocking job.
yeah,
You've also pointed out before, hi, sorry. Bobby's mentioned that not every alpha feature can be enabled by default for test when it replaces existing behavior. So priority and preemption replaces the scheduling queue with a new queue. And if we turned that on by default for tests, then we would not be covering production code in tests. So for descheduler, something new that
No, I'm talking about daemon set scheduling by default scheduler.
yeah. So I guess Avesh's idea is to not replace any of our tests or not enable this feature in any of the current tests, but have like a separate test
Yeah,
that has this feature enabled. This is a
yeah,
little different from the scenario that we talked about. We were thinking about enabling, for example, a feature, an alpha feature in our regular tests. And I was saying that if it replaces one of our functionality, then the one that is enabled by default will not be tested. So yeah. Okay. These are some of the things. We would also like to finalize the design of the scheduling framework in the next, hopefully, 1 month or so, or maybe ideally the next couple of weeks or so. I have already sent a PR to add the proposal, a design proposal for the scheduling framework. I have seen some very good comments and questions about the framework, and I would like to address those soon. I will do that hopefully this week. But if you also have questions and comments about the scheduling framework design, please go ahead and leave your comments on that PR. These are, I guess, all the items that I had in mind for 112. If you have any other ideas or comments, suggestions about, one more thing is actually gang scheduling. So Klaus is leading that effort, and he has some ideas. So far, our decision has been to create a separate scheduler for gang scheduling, basically to schedule batch jobs in a separate scheduler. The reason that we thought this might be useful or might be helpful is the fact that batch scheduling requires a set of different metrics and predicates, and we didn't want to combine all of those in a single scheduler. Another benefit of having a separate scheduler is, of course, the fact that we are balancing the load of the scheduler in larger clusters. I don't know how important that one is for us or how critical that one is, but it is something that could possibly help our larger customers.
yeah. I mean, it seems like that sounds like a daemon set controller that we have had for scheduling daemon set pods.
That is correct. So daemon set controller was a little different in a way because it was not a like full-fledged scheduler. It was a little bit different, but you're right. Are you saying that it could cause similar problems as the daemon set scheduler caused?
Yeah, I mean, yes, definitely. But I think, but if just for starting, like if you want to have that, that's not a bad idea. Yeah.
I absolutely agree with you. After a while, it always becomes hard to keep two
Yeah.
separate components in sync. Once we add a new feature, like for example,
Right.
preemption was an example that was a relatively complex feature that was hard to support in daemon scheduler.
Yeah.
And I agree with you that we probably run into the same problem in the future if we want to keep the two in a completely separate components. One thing that we wanted to do was to possibly use the scheduling framework for both of these two components. So basically, use the same structure for both of the two, but maybe they have different set of plugins. And if our plugins uh, are completely standard, that's what we are aiming for. Or if the plugins are completely portable for the framework, we should possibly be able to develop a plugin for the framework and use it in both of the places or both of these components.
Do we have a target for what we want to accomplish in 112 related to gang scheduling?
Oh, related to gang scheduling? We don't, but I would like Klaus to basically define the achievable goals for 112. I know that he already has a prototype. We were thinking about renaming Cube Arbitrator to something more relevant, like maybe batch scheduler or something like that, and focus on scheduling aspect of gang scheduling at this point. For 112, we can hopefully have a alpha version of the batches scheduler. But since Klaus cannot attend the 10 a.m. meetings, I would like to wait for him until the next meeting to see what he thinks. Do you guys have any other items that you would like to be discussed, or you would like to see some progress in 112?
I mean, so far, like, I mean, we haven't discussed internally concrete plans for 1.12. So, I mean, right now we don't. The only thing I think the only thing that is important for us a default that daemon set scheduling by default scheduler, but maybe like in the next 3-4 weeks, like when we have more discussion about 1.12, it might give more idea to us if we want to have anything else other than that.
Okay, sounds good. Yeah.
The sooner the better.
Yeah, and one more thing, I think like that scheduling policy, like I think we have been discussing, right?
Right. Yeah. That one is actually, that's a good point. We should definitely see some progress there too. We are kind of involved still in the process, but we thought that the policy team is probably a better place for leading that effort. We are going to be involved pretty heavily because it's going to affect the scheduling as well. But it's not something that we really need to implement on the scheduler side. These will all go to the admission side.
Right.
It's like all policy checks.
Right.
So it makes more sense for the policy team to be leading that effort. But you're right. That's something that we would like to see progress as well.
Yep.
All right. Any other items or ideas that anyone has, or any feature requests that you guys may have? Okay, so since Deepak is here, Deepak, do you have any updates for us from the Poseidon side?
Definitely, yes.
All right, please go ahead.
Yeah, so we finished our the Node Affinity a while back, a couple of weeks ago, and we did a release 02, and then we just finished a couple of days ago our Pod Affinity work.
Oh wow, that's
yeah. So I know, and we have taints and toleration done end of this month. I mean next week actually. So now the taints and toleration, and we have already started our work for doing the performance, the exercise, to find out where we are after putting all this code in there and see. So that's, we just started that. We're setting up environment. we're setting up a local cluster. We got pretty good resources local as well. And but at some point we are gonna go bigger, and then we're gonna go to GC as well. So next couple of weeks, 2 or 3 weeks. So the way we are doing is we're gonna, because we know that the pod affinity is a culprit, in the performance perspective. So we're gonna start out with the performance testing just for affinity, anti-affinity at the pod level, and then we'll slowly start mixing up the node level affinity, and then all rest of the stuff basically. So,
okay, great.
yeah, we'll have essentially, we're planning to have a mix workloads.
Excellent.
And we have a pretty, actually, so we have a lot of interest in China actually. So there are a bunch of guys involved, and they're helping out. The max part, for example, the max part, you can have, you can, like in Kubernetes, you can define the max parts 40 or 50 or whatever at the node level. So somebody took on that work, and then the other thing we need to do that is after we hopefully, we don't see any issue with the performance impact, because the way we are doing pod affinity, we have a lot of performance design. We store all the as the pods come in, we store it in a hash table in memory and all that. So I think it should be pretty efficient actually. So yeah. And then remember I mentioned that. So any pod which has a pod affinity definition, we queue them up basically, because there's a better way of doing it in a graph, in a network graph. But I think we had a lot of issues, and we've been working with Unal on that. But we didn't want to really get bogged down and then kind of boil the ocean at this time. So right now, so essentially as the pods come in, we queue them up for if they have any pod affinity, because we want to run them one by one basically.
Right. So one question is that, do you also support existing pod anti-affinity now?
Yes.
Okay.
Yes. Pod affinity, anti-affinity, node affinity, anti-affinity, node selector. Yes.
So basically, the particular problem with pod anti-affinity, or existing pod anti-affinity as we call it, is that the anti-affinity is symmetric. So if you have a pod already running in a cluster, then it has anti-affinity.
So this is the assumption. I remember last time we discussed. So the assumption we have made is so we essentially, as I said, we're queuing up pods if they have a pod definition. So that's the assumption we are making. So we're making assumption that the anti-affinity is explicit symmetry. Basically, if the incoming pod has the anti-affinity definition in it, only then we'll queue it up basically. So if it doesn't, because otherwise then we're gonna end up basically doing the queue up the whole thing. It doesn't really make sense.
So basically, I guess what you're saying is
that will be able to validate the behavior.
Yes, but I guess they expect that. So what I understood from what you just described is that you expect the anti-affinity rules to be symmetric, exist on pod in pod specs,
yes.
right?
Yes.
Yeah, that's a tough that's a tough assumption. I mean, it's very hard for users to make that kind of change to their pod spec, because sometimes they actually cannot do it simply because there are like multi tenants in a cluster. So you cannot go and ask all your colleagues to create the same like anti-affinity rules in all of their pods. It becomes a little harder to basically keep that promise. But
I think so. As I said, so the reason we have to do that is because we have to queue them up. See, so there's a better approach as well, which we were exploring with. I think there's a research paper which Unal and Malti wrote, and we started experimenting with that, but there were a lot of holes in that. So and then these guys, they got pretty busy, and we were not able to get feedback from them. So we just for the time being, this is what we are doing actually. So. Yeah, I mean, as I said, my argument for that would be the fact that, how often would you have anti-affinity, pod affinity? So when you do, you have to manually basically define that, you see. So as opposed to any incoming pod, you have to go and look.
I can give you one compelling use case. Google, for example, recently launched sole tenancy in GCE. So the idea of sole tenancy is that you as a customer go and ask for a node that is going to be running only your tasks. This is something that a lot of security applications require because they don't want to share the underlying resources with other non-trusted workloads, right? So when you want to do that in Kubernetes, you can easily put a pod anti-affinity rule, and when you reschedule, you can say only run tasks that have, for example, the label that is saying that this pod is from my user. And on this node, I don't want to have any other pods. So it's very easy to do with pod anti-affinity. But of course, other users of the clusters may not want to add that rule for basically your wish. So it's hard to assume that such a rule exists in all the pods.
Yeah, I agree. I think so. You're right. I think so. I think so. The concern would be that we're not really doing true comparison because we kind of expecting the behavior to be explicit. You see. So I think, but right now the way we are, we can, as I said, I think there's a better way of doing it. So essentially, we'll see if we can make progress down the road. But I think for the time being.
Yeah, that's fine. That's totally fine. But I just wanted to say that we actually.
I agree with you. Yeah.
This is what we. The reason that we have this rule is not just simply because we are unreasonable. There are really use cases for this.
Okay. Well, I think that's so. Is that the sole affinity you choose?
Sole tenancy, it's called sometimes. Sole tenancy.
That's at the Borg level or at the Kubernetes level?
So in Kubernetes, we used to have it actually. If you wanted to achieve sole tenancy, you could have an anti-affinity and label pods properly so that only pods from your users are basically owned by your user can be scheduled on that node, right? So you could set the topology to node and have an anti-affinity rule with the proper selector. But now. Actually, I built this feature in Borg when I was in the Borg team, and it's now released in GCE as well. So GCE supports it. That's at the VM level, essentially. So when we're talking about Borg, we're talking about physical machines. So that feature enables Borg or our users of GCE, GCP to specify that they want only their own workloads to run on a physical hardware or physical node.
Okay. Yeah, I think that's the other thing. I know it's kind of a side topic, but I started looking at Ray. Are you folks familiar with the Ray framework? The Berkeley guys working on the research project.
I have heard of it, but I'm not that familiar. No.
I think so. So it's essentially geared towards AI, iterative algorithms. So instead of writing your driver outside the cluster, you write within a cluster, and then you can define. But one of the interesting things was, I think that's kind of a side thing, from a scheduling standpoint, because they want a very low latency. They're using a distributed scheduler mechanism. Actually, these guys.
Right. That's actually, these are all good ideas. Sometimes distributed schedulers help. Sometimes they lead to more complexity and less optimal decision making about like scheduling. So it's a tough balance. Depends on the goals really. But we would definitely like to explore ideas there. And if we can actually build some of those ideas in the scheduling framework, it'll be great.
Okay. So I will definitely keep you guys posted, but I think that's definitely, so for the time being, we're going with the explicit anti-affinity thing, and then we'll start thinking about it. I think so. I had meeting with but these guys are pretty busy. So if we can nail so they're essentially coming up with a new design. He wrote that in his thesis, but it's not fully fleshed out. And when we started implementing it, we found a lot of holes actually. So that's why we didn't go that out. Basically.
I see. Okay.
So we had to queue them up. That's why.
Okay, that's fine. All right, thank you very much.
Just a quick question. So you published the design for your proposal for the scheduler. Did you guys discuss that yet, or I'm just kind of curious?
Yeah. Before you joined the meeting, I said that I've already sent a PR as a design proposal for the scheduling same place in our community, like design proposals. You can go find it, or I can possibly send the link to our whatever this.
I don't think it's been discussed in one of these meetings.
Oh no, we haven't discussed the details in the meetings, but the design is out there. You can go and read it. And
any plans or timeline, like a 112, 113 kind of thing, or is there any, or just a thought process kind of?
We are at this point. We are trying to finalize the design. Really, I don't think we can really have anything usable in 112. It's unreasonable to think that it's going to be
okay.
Even an early version is not going to make it to 112. I really doubt it.
Okay.
Maybe 113. Yeah.
And just one final thing I want to add is one of the things we're going to start looking at is this multi-scheduler thing. We know we have a lot of problems because our firmament scheduler, it becomes, let's say we get good throughput, it's still going to coexist with the default scheduler. We know there are a lot of issues, so we will work on that. Maybe we may have to make some changes at the Kubernetes level as well in order for us. So we'll that's another task we're going to do it after that.
Sure, that sounds good. Yes, we would like to address those as well. One particular area there is that we would like to make sure that our scheduler is aware of preemptions made by other scheduler. That's something that we definitely
the max part thing as well. So currently we have a max part implemented in firmament, which doesn't really know anything about the default scheduler, so it's broken basically.
Oh, I see. Okay.
We need to figure that out as well. There are a couple of other issues within firmament. So.
Okay. Sounds good. All right. Any other updates, comments, questions? We have about 2 minutes left. All right. You get 2 minutes, or actually 1 minute of your life back. Thank you very much for attending, and see some of you guys next week. Bye.
Thank you very much. Bye.